All right, if you're a web developer, I know you felt this pain. That moment you hit a brick wall, and that wall has a name. CORS. But what if I told you that wall isn't a bug? It's actually one of the most important security features we have. Today, we're going to demystify CORS and turn that frustration into a real understanding.
I mean, I'm willing to bet you have, right? You're building your app, you try to fetch some data from an API, and bam! The console just lights up with that infamous red error, cross-origin request blocked. It's a moment we've all had, and it feels like something is just fundamentally broken. But here's the twist. That error message, it's not a bug, it's a feature. It's a sign that a crucial security mechanism is working exactly the way it's supposed to. So in this explainer, we're going to unpack why that so-called error exists and how you can work with it, not against it.
To really get CORS, we first need to understand the fundamental rule it's built on. I want you to think of every website or web application as its own secure fortress. The browser's main job is to make sure one fortress can't just spy on another one. This whole fortress idea is enforced by something called the Same Origin Policy, or SOP for short. This is the default security setting for every single browser. It's like a high, invisible wall around each website, and it's there to stop a script on one site from, say, reaching over and reading sensitive data from another tab you have open, like your email or your online bank.
So, what exactly is an origin in the browser's eyes? Well, it's an incredibly strict definition. It's not just the domain name. An origin is the combination of three things: the protocol, so HTTP versus HTTPS, the host, and the port number. If even one of those three things doesn't match exactly, the browser considers it a totally different origin.
And just look at how strict this policy is in practice. Moving between directories on the same site, that's fine, same origin. But just changing the protocol from HTTP to HTTPS? Nope, that's a different origin. Using a different subdomain, like news instead of store, also a different origin. And get this, even changing the port number by one single digit creates a completely different origin. It's that precise.
Now here's the crucial detail, the part you really got to remember. The SOP's main job is to prevent a script from reading the response of a cross-origin request. You can often send a request, no problem, but your JavaScript code gets blocked from seeing what comes back. This is literally what prevents some random ad on a blog from making a secret request to your bank's website and reading your account balance.
Okay, so those fortress walls are great for security, right? But what happens when we actually want two different origins to communicate with each other? I mean, the modern web is completely built on this kind of interaction.
Just think about how any modern app works. Your front end, living on one domain, needs to grab data from an API on a completely different domain. You want to use cool web fonts from Google, or load a texture for a game, or draw an image from another server onto a canvas. Without a way for them to talk, the same origin policy would block every single one of these things we do every day. So we've got this dilemma. We need the fortress walls for security, but we also need to open a gate for approved visitors. We can't just tear the walls down. That would be a total disaster. We need a controlled, secure system. We need a gatekeeper. And that, right there, is the job of CORS. CORS, which stands for Cross-Origin Resource Sharing, is that gatekeeper. It's a protocol that allows a server to relax the same origin policy, but only in a very safe and controlled way. It's like a secure handshake between the two origins.
The key thing to understand here is that CORS is built entirely on HTTP headers. It's not a JavaScript library or some browser setting you just flip on. It's a formal conversation. And critically, it's the server that gets the final say on who is allowed to access its resources. The power is with the server. So here's how that handshake works in a simple case. First, when you make a request, your browser automatically tacks on an origin header. It's basically saying, "Hi, I'm calling from domain A.com. The server over at domain B gets this, checks its guest list, and if domain A is on it, it sends back a special header, access control allow origin. The browser sees this as a permission slip and finally lets your JavaScript code actually read the data.
Now, here's an important detail. CORS doesn't treat all requests the same. It kind of divides them into two camps. You've got your simple requests, things like basic GETs or old-school form posts that are considered pretty safe and can be sent directly. But then you have complex requests. These are the ones that could actually change data on the server, like put or delete, or use things like custom headers or send JSON. And these require an extra step.
For these more, let's call them complex requests, the browser takes an extra safety step. It doesn't just fire off the request, it asks for permission first. And this process is called a pre-flight request. The logic here is actually pretty simple and really smart. Before the browser sends a request that could, delete a user's account, it wants to be absolutely sure the server is aware of and actually permits these kinds of cross-origin actions. This whole dance prevents a malicious website from tricking your browser into sending destructive commands to an API you happen to be logged into.
So how does it ask? Well, behind the scenes, before your fetch or Axios call even really gets going, the browser automatically sends a tiny preliminary request using the options HTTP method. It's basically the browser asking on your behalf, "Hey server, I'm about to send a post with a JSON payload from this origin. Are we cool with that?"
And here's what that little conversation looks like. The browser's options request details what it wants to do, the method it's going to use, and any custom headers it's going to send. The server then responds with headers of its own, explicitly stating which origins, methods, and headers it's willing to accept. Only if everything matches up perfectly does the browser proceed with sending the actual post request.
Now you can imagine doing this pre-flight check for every single request would be, well, a little slow. So to solve this, the server can include an access control max age header. This number, 86,400 seconds, tells the browser how long it can cache this permission slip. So for the next 24 hours, the browser knows it's safe to send similar complex requests without having to ask first, which is a really nice performance boost.
Okay, so we've covered the theory. Let's get practical. What do you, as a developer, actually need to remember when you're staring down that dreaded CORS error in your console?
This might just be the single most important debugging tip of all. For security reasons, when a CORS request fails, your JavaScript code just gets a vague, generic network error. It's not allowed to know why. The real clues, like, hey, you're missing this header, or that origin isn't allowed, are only visible in your browser's developer console. So rule number 1 is always check the console. So let's recap the big stuff. First, and say it with me, CORS is a security feature, not a bug. It's your friend. Second, it's configured on the server. You fix CORS errors in your backend code by adding the right headers, not in your front end. Third, the browser console is your absolute best friend for debugging these issues. And finally, a super important security rule. If you're sending credentials like cookies, the server absolutely must specify an exact origin. The wildcard star just won't work in that case, and for good reason.
So, hopefully that red error message in your console looks a little less scary now. The next time you see it, you'll know it's not the browser just being difficult, it's the start of an important security conversation. So the real question is, now that you get the why, how will this change the way you design and secure your next application? Thanks for watching.